Alright, Assalamualaikum and very good morning. My name is Muhammad Ismail Hakim bin Muhammad Zaini. My metric number is 21DIT 24F1227. And as for today, I will do a presentation on my current assessment, which is the problem-based assignment. So before we get started into the presentation, I would like to state out the problem statement and the goal of this project. The goal here is the objective of this project is to implement an automated IoT environmental monitoring system, which is to analyze the relationship between multiple sensor, which is the light intensity sensors and the ambient temperature. So the system provides a data approach to climate control by using a microcontroller, which is the Node MCU ESP, and to acquire real-time data, providing the local feedback via the LCD component and the triggering the buzzer to alert whenever temperature reach a certain value. All right, so for the data acquisition method, I utilize the hardware acquisition by choosing the option B, which is we use the Node MCU ESP8266 microcontroller, and also with the DHT11 temperature humidity sensor and a light dependent resistor or LDR. So this localized hardware setup was selected to ensure the high frequency site specific data collection, unlike the general weather like the API. This method captures the exact microclimate of the testing environment, which is essential for the accurate descriptive statistical analysis and a real-time reactive logic like the buzzer and the LCD and many other components. As for the sampling strategy, a dataset of 100 samples was chosen to ensure that the calculated mean and standard deviation are statistically significant and reliable. And also the 15-second interval allow the system to capture rapid environmental shift while adhering to ThinkSpeak cloud database. And after we have done figure out the strategy and the method that we are going to use for this project, here is the implementation and visualization part. So for the implementation, I will provide a different video at the end of presentation. So right now I will first explain on the chart and the descriptive statistical result from the MATLAB analysis. So why did I choose the line chart aside from the other chart? So by selecting this line chart for the temperature, humidity, and lux, it allowed me to see the most effective time series, which is allowing for the clear identification of the trend or the fluctuations over a 25 minutes windows. So the exit range for the temperature was scaled from 0 Celsius to 50 Celsius, which provide a normalized view of the DHT11 sensor operational range relative to the 29 Celsius buzzer threshold. All right, here is the result for the MATLAB analysis. So for the mean, we have 27.48, for the median, 27.6, and standard deviation, 0.22, while for the maximum, 27.6, and the minimum is 27.10, which has 0.50 gap between them. So for the mean, it provides the baseline ambient thermal load of the testing environment, while for the median, it acts as a robust measure of central tendency. Unlike the median is not affected by the temporary sensor spikes or the outliers. Since since the mean we, since my mean is 27.48 Celsius and the median is 27.6, they are very close, which prove that my 100 and more samples dataset is highly consistent and follows the normal distribution. While for the standard deviation, it quantifies the stability of the dataset, which is a low standard deviation proof of high sensor reliability and environmental consistency. And for the maximum and the minimum value is actually the a simple data. It identifies this extreme range to verify if the safety threshold, which is the 29 Celsius limit, was breached or not. All right, so at the end of the project implementation of this environmental monitoring system, it's actually successfully demonstrate a complete data lifecycle from hardware-based acquisition to cloud-based statistical interpretation. So by integrating the non-MCU ESP8266 with the DHT11 and LDR sensor, the project achieved a high-resolution dataset of 100 and more samples, so fulfilling the requirement for the statistically significant study of the microclimate stability. And The inclusion of an 12C LCD and a piezo buzzer provided a robust local interface, allowing for immediate edge-level decision-making when temperature exceed or equal to 29 Celsius safety threshold. So, furthermore, the use of MATLAB analysis, specifically the implementation of data cleaning via the omnitent function, it is actually to ensure that the final mean and the standard deviation were accurate and professional. That's all. So the project confirmed that integrating the low-cost hardware with the advanced cloud analytics like ThinkSpeak provide a powerful, scalable solution for a real-time environmental oversight and automated climate response. So here we have our circuit on for this assessment. So here we have the buzzer, the humidity and the temperature sensor, and the light sensor, and also the non-MCU ESP8266, which is our main brain controller for the whole circuit. And also we have the LCD here, and the current value show that the temperature is currently now 27.6 Celsius and the humidity is 47, while for the light is 248 luxes. So to prove that all these values are right or wrong, we can actually test it. So for example, here's the light is currently on 250 lux. So if we cover the light sensor, it will go down. So from 200 it goes back to the 47 lux. So this actually proof that the sensor is working properly. So for the temperature and the humidity, both of these values are actually related to each other. So the current temperature is 27.60 Celsius and the humidity is 48. This is due to my air conditioner, which is powered on. But I can show the other value from the cloud from the ThinkSpeak. And for the buzzer, it will goes on whenever the temperature goes higher or equal to 29 Celsius, like in the code. So here we have the logic control buzzer. So here the T stands for the temperature, and whenever the temperature goes higher or equal to 29, the digital writer will set the buzzer pin as high, which is will goes on. So here it is. And alright, and here is the serial monitor that show that our data is actually sent to the or update to the ThinkSpeak. So here is the ThinkSpeak website. So we can actually see it's currently on 318 entries, which is more than enough, more than the assessment required us to do, which is the 100 samples. We have 218 more than that. So here is the temperature, which shows that the latest data is sent on 12:03 minutes, which is currently on right now actually, and the current temperature is 27.1, which is the same as the LCD, 27.1. And for the others, humidity sensor is actually the current value is 47, which is the same as the LCD also, and the current light is actually 200 plus. If it goes to the lux, it will show that it's on 177. Yep, right now 178. So here it is, and here is the MATLAB analysis. So this whole code is actually for automatically calculate the value of mean, which is the average value, and the median, the standard deviation, the max, and also the minimum value of the temperature. So here, if we save and run the code, it will automatically show the value. So here we have our mean on 27.77 Celsius, and the median is 27.6, while the standard deviation is on 0.46, and also the maximum value of the temperature is 28.9, and the minimum is 27.10. So to prove this value is right, so we can check the minimum value. So if you go back to the data chart on the temperature, we can actually see the lowest temperature we have is currently on 27.1. So the minimum value is actually right, 27.10. So for the maximum value, we can actually see back here, It's currently on 27.6. This is due to too many entries. We have more than 100, so that's why we cannot see the other on back here. So yep, that's all from me, and thank you.